it is given that the arithmetic sequence, that one. And what's an arithmetic sequence? It's a sequence whereby you obtain the next term by adding a common difference from the previous term. And how do we calculate the common difference? The common difference will be equal to Tn minus Tn minus 1. And we say it's the term in front minus the term behind. So in this particular case, to get the common difference here, we are going to say 1 minus 3. 1 minus 3 is going to give us a 4. So our common difference in this case is 4. Then you are asked, the first part is saying determine the formula for the nth term of the sequence. Generally, the Tn of the sequence, that is now question 3.1. Question 3, sorry, Tn will be equal to a plus n minus 1 d, where the a is the first term, but in this case our first term we are given as negative 3, so it means this will be equal to a plus, what's our n? If we want Tn, so our n minus 1, what's our common difference? Our common difference is equal to 4. Substitute the 4 where there is d. Simplify. This is going to give us minus 3 plus, going to give us 4 is going to multiply the n, so it's going to be plus 4n. That 4 is going to multiply the negative 1, then we get minus 4. You are leaving minus 4, which is going to be equal to minus 7 plus 4n. Comes our answer. Alternatively, we can get our Tn. Alternatively, we can get our Tn to be equal to dn plus c, where our d is the common difference, so it means our Tn is equal to our d, which we agreed is 4, so it's going to be 4n plus c. When we want to get the value of the c, it means we have to check any term that we are provided. We have to check any term that we are provided. In this case, we see we are provided first term, second term, third term, and the last term. We don't know its position, so it means we can use either first term or second term or third term. So if we use first term, it's going to say our T1 is equal to, our T1 is equal to negative 3. Our T1 is equal to negative 3. So we substitute negative 3. It's our T1 must be equal to, in the formula for Tn, wherever there is an n, we are going to substitute a 1. So we are left with the negative 3 being equated to 4 plus c. Solving for c, we transpose this one. Always remember that when we transpose, the sign changes. So if we leave our c there, our minus 3, we're taking the 4, it becomes minus 4, must be equal to c. Our c therefore is equal to negative 7. Hence, our Tn. In our next question, question 3.1.2, we are required to get the fourth. If we check this, write down the fourth, the fifth, the sixth, and the seventh term. So since we have term 1, term 2, term 3, and we have identified that our common difference is 4, we can get the next terms by adding from the definition of arithmetic sequence, whereby we say we get the next term by adding the common difference. So it means Here we have our T3, which was equal to 5. To get our T4, it means our T4 will be equal to 5 plus the common difference, and our common difference was 4, calculated earlier on. We need to say our T4 is equal to 9. To get our T5, it means we are going to say T4, which is 9, plus our common difference, which is 4. So this is going to give us 13. Then to get our T6, it's going to be equal to T5, which is now 13, plus our common difference, which is 4, which is going to give us 17. Then to get T7, we are going to say T6, which is 17, plus our common difference, which is 4. Therefore, we are going to get 21. Alternatively, since we have determined that the formula for Tn, is given by 4n minus 7, we now want T4. If we want T4, it simply means on the position for n we are going to put 4. So it's going to be 4 multiplied by the 4, which is now our n, minus 7. Simplifying that, 4 times 4 is 16. 16 minus 7 is going to give us 9. We go to T5. If we want T5, because we have our Tn, it simply means wherever there is n, we are just going to put 5. So it's going to be 4. Then our n is 5. We substitute 5 minus 7. Then 4 times 5, it gives us 20. 20 minus 7 is going to give us 13. We want our T6. That will be equal to, if we check, we have our Tn, so it's going to be 4. Where there is n, we are going to put a 6, then minus 7. So it's going to be 4 times 6, which is 24, minus 7. 24 minus 7, it gives us 17. Then we go to T7. T7, it simply means at the place of n, we have to put 7. So it's going to be 4. Place of n, we are just going to put 7. Then minus 7. 4 times 7 is 28. 28 minus 7, we get 21. Now we have our first term as -3, followed by 1, followed by 5. Then the other 4 term to the 7th term, we calculated them, we found them to be 9, 13, 17, then 21. These are the first 7 terms of the sequence. So if we divide each term by 3, that is, we are now on question 3.1.3. you'd realize that write down the remainders when each of the first 7 terms of the sequence is divided by 3. You are just dividing all those 7 terms by 3. Then you check the remainder. -3 by 3. -3 divided by 3, you'd see the remainder is 0. Then 1 divided by 3, the remainder is 1, because we get an answer of 0, remainder 1. On 5 divided by 3, it's 1, remainder 2. Then 9 divided by 3, the remainder is 0. 13 divided by 3, the remainder is 1. 17 divided by 3, the remainder is 2. Then 21 divided by 3, the remainder is 0. So the question was saying write down the remainders when each of the first 7 terms of the sequence is divided by 3. So the remainders are 0, 1, 2, 0, 1, 2, 0. So in the last question, you are required to calculate the sum of the terms in the arithmetic sequence that are divisible by 3. So the first term is going to be minus 3 because we realize that minus 3 is divisible by 3. Then the second term is going to be 9. That's the next term that we found that it was giving a remainder of 0. Then the third term is 21 of the new sequence, one numbers that are divisible by 3. And we have terms in between. Then our last term is going to be 393. As we can see, the term 393 is exactly divisible by 3. So this is we now to answer the question 3.1.4. It means we are now using a new sequence, but we want the sum of arithmetic sequence. Then you copy the formula from the formula sheet, which gives you Sn equal to n over 2 open bracket a, sorry, it's 2a n over 2, then we have 2a plus in brackets again n minus 1 d. Here we now have new variables. We have our n. We have to see how many terms are in the sequence. Our a is 2 minus 3. Our n is still yet to be defined, and our d, it means it has changed. To calculate our d, we just use the formula for calculating our d. Let's just come here. Then you say 21 minus 9, we are getting 12. So it means our d for the sequence is equal to 12. Then to check how many terms are in the sequence, we are going to use the formula for Tn equal to Tn. We use the formula for Tn equal to, so let's go and use the formula for Tn. There we want to check how many terms are in the sequence. Tn equal to a plus n minus 1 d. Then our Tn, we take it to be the last term. Our Tn, we take it to be the last term. So our last term in this case is 393. 393 must be equal to our first term, it's negative 3 plus n, we don't know our n minus 1. Our d, we found it to be 12 now. So when we simplify, we are going to have our Tn, which is 393, which is going to be equal to negative 3. The 12 multiplies n, so we get positive 12 n negative 12 when we multiply the negative 1 and the 12. If we simplify, we are left with 393 plus 3 plus 12 being equal to 12n, and that amounts to 396,408. The total on the left hand side, which is equal to 12n. To get the value of n, we divide both sides by 12. We divide both sides by 12. Then our n will be equal to Here we punch on our calculator. So 408 divided by, it's going to be 34. So it means now the new sequence is having 30. So it's gonna be now S 34 being equal to 34 over 2 open bracket 2a, but the a we found it to be negative 3 close bracket plus n minus 1. The n we said is 34 minus 1 times the d which we said it's now a 12. Then we punch on our calculator to get our answer. Our answer punching on the calculator is going to be 34 divided by 2 multiplied by 2 times minus 3, we close the bracket, plus open bracket 34 minus 1 times 12, which is giving 6,000. The answer is giving 6,630. 6,630. Alternatively, it was possible that we use the other formula for SN, which incorporates the last term. So if we were to use that formula, it means it was going to be Sn equal to n over 2 open bracket a plus l. So it means you needed to know how many terms are in the sequence, and the number of terms that are in the sequence have been calculated, and we found them to be 34. So it means we want the sum of first 34 terms. So it's going to be it's gonna be it's gonna be S34 being equal to n, which is 34 divided by 2 open bracket, first term is minus 3 plus the last term, which is 393. So punching on the calculator there, we are going to have our final answer is, from the calculator, is 6,630. As 6,630. Thank you.